All right, number 3 is where we start to get into those ICE tables. And how do we know we need an ICE table as compared to the other ones? It's because they told us some starting conditions and then they told us some equilibrium conditions. So we're going to have to keep track of all of this in one of those ICE tables, because where you start is certainly not where you end. We're going to have to figure out what you start with, how much it changed by, and what equilibrium is. So I'm just going to go ahead and rewrite our equation here. So it's 2NOBr, and that's going to be in equilibrium with 2NO and then Br2. And everybody is a gas, and a gas, so it's fine. And I want Kc, so I can just go ahead and set up this equation. So that's going to be the concentration of NO squared times the concentration of the bromine divided by the concentration of the NOBr squared. But again, remember that these guys here are equilibrium values. Not where you start, but where you get to equilibrium. So all of those have to be equilibrium values. So I've got an I got a C, and I got an E. So I is my initial, C is my change, and E is my equilibrium. Now what did it say? It said I started with 0.75 molarity of the NOBr. So that is 0.75. It did not say that I started with anything here and here, so I can reasonably assume that those are zeros. Otherwise, they would have told me. Now, what did it say? It said 89% has reacted away. So, how much is 89% of the 0.75? So, 89% of the 0.75 is about 0.668. So, you're going to lose about 0.668 here, which is your 89% that it talked about. 89% of 89%, what's going on here? 89% of the 0.75 is the 0.668. So we're going to lose that. So that means we lost 0.668. So 0.75 minus the 0.668 gets us 0.082. So this is 0.082 that is there, right? Okay, now we got to keep in mind that the change line is what actually occurs in the reaction. So the change line stoichiometry must be maintained. So if there is a 2 here and a 2 here, that means I must have actually gained 0.668 here. And here I'm going to gain 0.334 because there's only a 1 there, because this is a 2-to-2 ratio. And this is a 1-to-2 ratio that is there. So, consequently, then, at equilibrium, I have 0.668 and 0.334 here. Now, I have my equilibrium values. And these equilibrium values can be plugged into this equation. And so my Kc then is going to be equal to 0.668 squared times 334 divided by 0.082 squared, because the equilibrium values are the only ones that go into this equation here. So it looks like I have 0.668 and another 668 and a 334, and I divide that by 082 and 082 again. Looks like I got about 22.2 here as my answer. So it looks like that one there is your guy.